Hello everyone, welcome to this class. I hope you are doing good and you are the best of your health. So after learning concepts of units and measurements, let's go and practice the question based upon JEE main pattern exercise. In this topic, we'll be talking about one option correct as the right answer. We'll be having multiple choice question in which one option will be the correct answer. If you mark correct, you'll be getting +4 marks. If you mark incorrect, you'll be suffering -1 marks. Now without taking more time, let's go to the first question. Force F is given in terms of time t and distance x by F is equal to a sin ct plus b cos dx. Then the dimensions of a by b and c by d are given by a ml t power -2, m power 0, l power 0, t power -1, b some options, c also, d also. We have to check which option matches with our response. Now see that force given is a trigonometric function. F is equal to a sin ct plus b cos dx. It's a trigonometric function. Let me tell you, the values, this trigonometrical values, this will have no units. So inside term, again this is having no units. Here also to be having no units, and this term a and b, they will be having the units of the variable expressed here. That is, a will be having the units of force, b will be having the units of force. That is, a is in Newton, b is in Newton. So if we take the ratio a by b, that will be unitless quantity. That means that will be having no powers of mlt. That is m power 0, l power 0, t power 0. So let me write the unit of a and b as unit of a, that will be Newton. So I am writing n. Same unit of b, that will be also Newton. I am using n for it. So a by b will be unitless. A by b, that will be unitless, or a by b dimension will turn out to be m power 0, l power 0, t to the power 0. We have got the dimension of a by b. Now let's go with the c by d. I told you here we will be having no units. C into t is multiplied sin ct. That is, c will be having the unit per second, because t will be having the unit of time, that is second, c will be having the unit per second. So I am writing the dimension of c, that will turn out to be m power 0, l power 0, and t power -1. Now let's go with the d. Here there should be unit, this quantity should be unitless overall. X is actually distance, that is the length or distance. So d will be per meter, that will be l power -1 if I talk about dimension. So d will be having a dimension of m power 0, l power -1, and t power 0. So I am using m power 0, l power -1, and t to the power 0. This will be the dimension of d. Now if we express c by d, see what we will be obtaining. C by d, m power 0, l power 0, t power -1. If we write in terms of dimension, m power 0, l power 0, t power -1, and for d we are having m power 0, l power -1, m power 0, l power -1, and t to the power 0. We have written this. Now easily we can find out the dimension of c by d. That will turn out to be, m will be having no role to play, l power -1 we are having here, it will move up, it will become l power +1, this will become l power +1, and here we will be having t to the power -1. C by d we got this. A by b has got no dimensions, so m power 0, l power 0, t power 0 for a we have, a by b, and m power 0, l, t power -1, that is for c by d. You can check for c by d, here it's m power 0, l power 1, t power -1. So the option that is matching with the right answer, that is option number C. So we will mark option C as the right answer. Rest all options are incorrect. So you need not to worry about them, they are incorrect. So this is how we are going to find the dimension of given values and variables. This question is asked in one of the previous examination. So you may understand, you may get the idea of what kind of questions do come in your JEE main examination. Let's go ahead with the next question. 2. The velocity of water waves may depend on their wavelength lambda, the density of water rho, and the extent to gravity g. The method of dimensions gives the relation between these quantities as a v square is equal to k lambda power minus 1, g power minus 1, rho power minus 1, b v square is equal to kg lambda, c v square is equal to kg lambda rho, and d is equal to v square k lambda cube g power minus 1, rho power minus 1, where k is a dimensionless constant. So we have provided with how v square is related to all of the given variables. So in such kind of question, since we have to check the dimension, you shall know the dimensional formula for the left hand side variable and the dimensional formula for the right hand side variable. If a equation is to be valid, it has to be dimensionally satisfying, it should be actually dimensionally correct. That is, the dimensional formula for v square should be equal to dimensional formula of the right hand side term. Now which term is going to match with the dimensional formula for v square? Let's check it. First of all, let's write the dimensional formula for v square, that will be equal to m power 0, l power whole square and t power minus 2. This is the dimensional formula for the first option. V square we have written. Now check for k is constant, so need not to worry about it. Lambda power minus 1, g power minus 1, rho power minus 1. I am going to write the dimensional formula for lambda power minus 1, g power minus 1, rho power minus 1. Lambda power minus 1, g power minus 1, rho power minus 1. Let's keep up the dimensions. Lambda power minus 1, can we write it as L power minus 1? Only I am using the required variables. G is Lt power minus 2 because it's an acceleration. This will become L power minus 1 t to the power plus 2. Since it is minus 1, you have to multiply. Rho power minus 1, you see it will become. Rho is what? It is density. Density is mass per unit volume. Then power 1 is also there. Mass per unit volume, I am multiplying the power minus 1. L power minus 3 will become L power plus 3. So we got this. Let us multiply. We will be having m power minus 1, L power minus 1 and plus 3. So we will be having plus 1 only. So L power plus 1 and t to the power 2. This is the term we will be having m power minus 1, L power 1, t power 2. Again you see this is not matching with this v square. So this option is incorrect. B1, let's check v square kg lambda. Let's check for g into lambda. So for g into lambda, this will turn out to be Lt power minus 2 and lambda will be L. So you will be obtaining L square, L power 2 and t to the power minus 2. And yes, that matches with this option. That matches with this option. So we got that kg lambda will be the right answer. We have checked. Luckily, we got at the option number B, that is the right answer. It's a single choice correct question, so rest of the options will be incorrect. So if you, for your satisfaction, you can check for C and D, you'll get that they are not satisfying with the dimensional formula for V square. Hence, they will be incorrect. So the only option correct will be option number B, that is V square is equal to kg lambda. Also, luckily, we got at the option of B as the right option, so we need not to check option number C and D. So this was about checking any formula using dimensional analysis. Let's go with the next question of the class. Question number 3. In a vernier caliper, I have also discussed in the first chapter the concept of vernier caliper, how to use it. In a vernier caliper, n division of the main scale coincide with n plus m divisions of the vernier scale. N division on the main scale, remember this, n divisions of main scale coincides with n plus m divisions of the vernier scale. What is the value of m for which the instrument has minimum least count? We have to give the minimum least count for it. What will be the value of m? Option A 1, B capital N, C n by 10, D n by 2. 4 options we have. Let's check which option matches with the right response. For it, what we are going to do, we are going to use the formula for least count. Already I have discussed the formula for least count with you all. Least count is value of one main scale division minus one vernier scale division. Here it is given that n division of main scale coincide with n plus m divisions on vernier scale. So n into main scale division is equal to n plus m into vernier scale division. From here can we write one vernier scale division will be equal to n upon n plus m. N upon n plus m main scale division, that is what we need to write. Main scale division, we'll be getting this for one Vernier scale division. Now what is the value of least count? That will be 1 MSD minus 1 VSD. Let's do that. Least count is equal to 1 MSD minus 1 VSD. This is what I have already depicted. Just put up the value of VSD in terms of MSD. We will be getting 1 MSD. I know that from MSD you must be recognizing a famous cricketer, but here we are using for main scale division. VSD, that is actually equal to n upon n plus m, n upon n plus m multiplied with MSD. Now MSD can be taken common, and 1 minus n upon n plus m, let's do that, is equal to MSD, and here we will be having 1 minus n upon n plus m. This term we obtained. Now simplify this. You will be having main scale division, 1 main scale division multiplied with n plus m minus m, you will be getting m upon n plus m. Simplify it further. So this will be MSD, 1 main scale division, divide by small m, both numerator and denominator, we will be obtaining 1 upon 1 plus n by m. This is the value of least count. We need to have the minimum least count. For minimizing this term should be maximum. Sorry, for minimizing this term, the denominator should be maximum. That is what I mean. Denominator has to be maximum. The denominator will be maximum when this term is maximum. This term will be maximum when m is minimum. And m is any integer. It can have a minimum value of 1. So m, its minimum value will be equal to 1. That is the only possibility. So for having the minimum least count, the value of small m should be equal to 1. Option number A matches rightly. So option number A, which is the 1, that is the right answer. I hope that you must be remembering the concept of vernier caliper and how to solve questions based on vernier caliper and measurement. Quite good question. Hope you have understood how to use the vernier caliper question with this question. Third one, let's go with the fourth one. The external and internal diameters of a hollow cylinder are measured to be 4.23 plus minus 0.01 centimeter and 3.89 plus minus 0.01 centimeter. The thickness of the wall of cylinder is A, B, C, D. We need to find out the thickness. Cylinder's exterior and interior diameter is given. Internal and external diameters are given. How the cylinder will be made? The cylinder will be somewhat like this. As you can clearly identify with this diagram, it will be somewhat like this. It's given that the external diameter comes out to be, you see the integer value, 4.23. Let me mark this external diameter. Diameter is given, so I am using the complete line to express the diameter. External diameter is given as, let's say it's D1, and internal diameter is given as D2. So can we find out for thickness? You see, we have to find out this thickness. Let's say the thickness is T. So 2T will be equal to D1 minus D2. Quite obvious, we can write 2T will be equal to D1 minus D2, that you can easily identify from the figure. Thickness I am identifying, T plus D2 will be equal to D1. So D1 minus D2 will be equal to 2T. D1 value is given as the diameter, external diameter, 4.23 plus minus 0.01. 4.23 plus minus 0.01 minus internal diameter, that is given as 3.89 plus minus 0.01, 3.89 minus 3.89 plus minus 0.01. Both are in centimeters, so I am not using that, both are in centimeters. This is equal to 2T. The integers, the main part of the answer, this will be actually subtracted. This term will be subtracted from this term. So 4.23 minus 3.89, you will be getting 0.34. 0.34 and plus minus 0.01. Remember, in addition, the error will remain the same, that will be 0.01 in while adding, that will remain the same. Let's go, we need not to actually subtract it, we have to keep the same as the error. Don't subtract this, the error will be still 0.01. Let's go ahead with the thickness, that will be equal to just divide by 2. So you'll be getting 0.17 with the same error 0.01. This will be in centimeters. So the the thickness value comes out to 0.17 plus minus 0.01. Let's go to the answer. 0.17 plus minus 0.01 centimeter. Option number C. That's the right answer for this given question. So I believe that, remembering, I have taught you all about the different cases of errors that occur in a measurement while measuring, while taking any reading. I hope that you must be clear about these things. Let's go with the next question. Question number 5. The Vernier constant of a traveling microscope is 0.001 centimeter. 0.001 centimeter. If 49 main scale divisions coincide with 50 Vernier scale divisions, 49 MSD is equal to 50 VSD, this is what that has been provided, then the value of one main scale division is A 0.1 mm, B 0.5 mm, C 0.4 mm and D 1 mm. Given the least count, given the main scale division which coincides with the number of Vernier scale division, that is what has been provided. We need to find out one main scale division, how much its value is. Again, using the concept of least count is equal to 1 main scale division minus 1 Vernier scale division. This is what I have taught you all. Now see here, 50, you see here 49 main scale division. Okay, let me use first 49 main scale division is equal to 50 Vernier scale division as per the given information in the question. From here you can write 1 Vernier scale division is equal to 49 by 50 main scale division. This is what we can write. Can we express VSD here in terms of MSD? So we can write least count is equal to 1 main scale division minus 1 Vernier scale division, that is equal to 49 by 50 main scale division. This is what we can express. So 50 minus 49, 1 by 50 main scale division will be equal to least count. Least count is given as 0.001 centimeter. 0.001 centimeter is the least count. So one main scale division turns out to be 50 into least count. That is 50 into 0.001 centimeter. This will turn out to be 50 into 0.01, straight away you can do that. It will turn out 0.05 centimeter. That is 0.5 mm. So the value of one main scale division is 0.5 mm. This is what we have obtained. That is actually equal to also 0.05 centimeter. 0.5 mm. Option number B clearly matches. Rest all the options are incorrect. Till now we have done the questions on least count, Vernier caliper, error measurement. We have done. We have given the value in terms while subtracting. We have given the value. Now these are the first 5 questions, first 5 important questions for your JEE main pattern exercise. I believe that it would be proving to be helpful for your preparation. I will come with the next 5 questions in the next class. Till the time, I wish you all the very best and thank you everyone.